Now let's expand our multiplication. Now we have a binomial times a binomial with multiple variables involved. Notice that this is set on up where I could FOIL. FOIL said first term times first term. So x times 3x produces a 3x squared. Outer terms, x times a negative 5y produces a negative 5xy. My inside or inner terms, 4y times a 3x. That's right, a positive 12xy. And last term times last term produces a negative 20y squared. Look to see if there's any like terms I could add or combine. Negative 5xy's plus 12xy's gives me a positive 7xy's. And then I just continue with my simplification. So there's a process of multiplying binomial times binomial, which we could use FOIL. It just happens to have multiple variables, and that's fine. Let's look at another example. 5x plus 3y squared. Do you recognize that as one of our special products? I hope so. This fits into the a squared. Well, if I wrote it as a plus b squared, that equaled a squared plus 2 times a times b plus b squared. So 5x squared, that produces a 25x squared plus 2 times the first term times the second term. Now, I'll write it all out this time. Plus my last term squared, which is 3y, square that makes it a 9y squared. And then let's just clean it up just a little bit. 25x squared plus 2 times 5 times 3, which is a 30, xy's plus a 9y squared. So if I recognize it as a pattern, I can just use that pattern that we developed before. It works with polynomials in one variable. It works with polynomials in multiple variables.